All right, guys, we're back at it. Day 5 of the 100 Days of LeetCode. We are going to be doing a LeetCode classic. A classic. It's going to be add two numbers. The second problem on LeetCode. The first medium problem on LeetCode. Let's get to it. All right, so let's give the problem a read. So, you are given two non-empty linked lists representing two non-negative integers. The digits are stored in reverse order and each of their nodes contains a single digit. Add the two numbers and return the sum as a linked list. You may assume the two numbers do not contain any leading zero except the number zero itself. So the first example, we've got the list as the head being 2, then 4, then 3, and now we have 5, then 6, then 4. So these numbers, like it says up here, they're stored in reverse order. So this number is actually, if we think of it in the form of a number, 342. And then this one would be 465. This is the answer, of course, because if you take these two numbers backwards, add them together, you get 807. And that, in the output, is expressed as 708. There's the explanation. Pretty straightforward in terms of doing that. Does get a little tricky implementing the linked list, but we will get there. So here is just another input. It's a little bit more complicated, and we'll have to check for this in our solution, because here we have this one, which is a 7-digit number, if I can count. This one is a 4-digit number, and then we are, of course, going to be getting a 8-digit number, because we have all 9s, of course. That makes sense. Threw me for a loop for a second. I haven't looked at that example in a while. But anyway, let's solve the problem. All right, so maybe you're noticing my obnoxious use of transitions, but it is 3:13 right now, and I literally just learned how to use them, probably at around 2:47 today. So I'm gonna be laying it on pretty thick with them while this infatuation stage is still going. All right, so you don't care about that. You care about the solution. Let's do it. Okay, so first thing is we want to basically initialize a dummy list node. Also, list node is an object that's, if you're using Python 3 like I am, or Python, it's going to be defined up here for you. So basically we can see that in that object there's a value, and there is there's a thing called next. And if you know anything about a linked list, it's shown pretty well over here. You have the list node, and it is the value, and then it also has a next. So this points to the next list node, and then this list node has a value, which is 4, and then it has a next, which is pointing to this list node. So that's what that next is, that's what that val is. So what we need to do initially is we need to basically say, this is going to be a dummy list node, and it's going to become clear how we're going to use that. So we are going to be using an iterative solution to this. So basically, we need to define another pointer essentially to a the list node that we just created, and we also need to define a carry variable, because if you notice here, sometimes our sum is going to be more than one digit, as in 4 and 6. That's 10. So in that case, we would need to have a carry. Simple addition, you learned it in first or second grade. Carry the 1. That's what we're going to be doing. Okay. Now we say, well, L1 or L2 or carry. So the reason why we're saying this is because we're going to be doing addition in any of 3 cases. So while there's a value still in L1, which would be the list node that we're currently pointing to in the first list. So while that isn't none, we need to do addition. While L2, which is the value that we're pointing at in the second list node, isn't none, we need to do addition. Or if there's a carry, even if we're done with the two lists, list one, list two, we still need to do addition, and that is what happened in this situation here that tripped me up before. But that's essentially why we get the extra pointers, because we're basically carrying that one. So we still need to enter this loop even if we're done with L1 and L2. So V1 is going to be equal to L1.val if L1, else it's going to be equal to 0. So this is our first value from the first linked list. You can say the same for link 2 if L2, else 0. And then what we're going to do is we're going to say val equals v1 plus v2 plus carry. And that's not a plus, that's an underscore. Okay. So now we have the value at the current stage in the list. And another thing we need to do is we need to say that carry is value divided by 10. If you notice in Python, this is the operator for integer division. In other languages, it'll just do integer division, excuse me, by default. If you're using integers, not so in Python, you have to tell it just because it deals with numbers a little bit differently. So basically, if this number is over 10, or if it's over 9, I should say, if it's 10 or more, this carry is going to be 1. Otherwise, it's going to be 0. And then our val equals val modulo 10, because again, we might have 13 here, but for that particular spot in the linked list, we're only going to be storing 3, right? And then the carry gets brought over to the next one. So now what we can say is we can say cur.next equals list node, val. So essentially what we're doing with this is we are taking this next and we're creating a new list node with next none, right? Because we're not there yet. And its value is going to be this val that we came up with. So we start with the first list node, excuse me, and we're basically going to be doing this throughout the whole time. And you'll see why we're doing cur.next here, excuse me, and why we never actually initialize this current value. So we do cur.next, and then we say cur equals cur.next. So now we're moving that forward, and in the next iteration of the loop, our cur value is going to be different, and when we do it next, it'll be onto the next list node. And we say L1 is equal to L1.next if L1 else none. So basically, if there's a next value there, that's going to be our new L1, else there's none. Same thing, excuse me, with L2. Okay. And then what we're going to do is we're going to return dummy.next, right? Because this dummy variable, it hasn't been initialized with a value, but the one that it's pointing to, which is cur.next, because in here, in the first iteration of the loop, there gets a cur.next value, it's going to have something that it's pointing to. So that's why we're returning dummy.next. And then, yeah, let's submit the code. Cool. There we go. That's add 2 numbers. Take care. Like, subscribe if you liked it. We've got 95 more days of this. Oh my God, why did I do this? This is so long, 100 days, but whatever. I committed to it, so let's do it. Peace.